So basically what we're going to do is 2 lectures followed by a quiz, right? So today is lecture 1, Metallurgy class 2. You got to have 30 of these babies before you're done. So only 28 more to go, right? Alright. We're going to start with defining what metallurgy is. The science and study of the behaviors and properties of metals and their extraction from their ores. So metals is a very generic term, right? There's tons of metals, right? Tons of metals, periodic table elements, right? We usually, in the welding machining world, stick to 3 main metals, right? Steel, stainless, and aluminum. There's obviously many other metals that, get welded and machined, but those are the main 3. So behaviors and properties. So what happens when you heat it up? The carbon steel gets all screwed up, right? Aluminum, if you heat it up in one spot, it travels really fast, right? So the heat travels through it, so that's a property, right? Stainless doesn't rust, right? That's a property, right? Those are all, that's a chemical property, a thermal property, and then kind of atomic properties, I guess. Depending on what you're doing with the carbon steel, right? Based off of the definition, at the end it says extraction from their ores. That's where the metal gets pulled out of the ground and gets formed into something that is useful, right? You're not going to go out and dig a hole in the ground and find a 4x8 sheet of 1/8" steel, right? Maybe it's scrapyard, I don't know, who knows, but for the most part that's not going to happen, right? They got to produce it. Some of the stuff that's made things better over the years, recycling, right? So like if you want to make some side money, what do? You go steal some metal and take it back to the scrapyard, right? See the people down there by the scrapyard all the time, rolling with a shopping cart full of whatever, bike parts. They're melting them back down, right? And you get paid for it too. So scrap isn't exactly what everybody thinks it is. You got to have like a ton of steel in order to get any money. It's not like you take back a shopping cart full of bike parts. You're probably gonna get like $5, So, anyways. So you don't have to take it from the ore for recycling is basically what I'm saying, which makes the process a lot better because it's not as long of a process, right? So that's what we're going to start with, ores, okay? Extractive metallurgy. There's the separation of the metals from their ores. Different types of ores. So that's just a definition of the term. Extractive metallurgy, the separation of metals from their ores. You got to get the metal out of the ores, right? If you watch the old blacksmith shows, we'll watch a video here at the end where there's like, I guess it's probably a club of Obana. Is that how it's said? I don't know. It's basically a blacksmith club. Anybody know what it is? Reese?
What?
Are you a member of Obana?
I'm not.
You're not. I thought you were into that stuff.
Yeah, I don't even know what you're talking about right now.
You don't even know what I'm talking about? Let's take a look. There's been a lot more in the blacksmith world because of that show on whatever station it's in.
Horse fight?
Yeah. Let's see. Blacksmith. I want to say club.
Colt.
Gold? New York State Designer Blacksmiths.org. I didn't even like this thing. Let's see. Maybe it's not around anymore, I don't know. I thought it was there. Oh, right there. There it is, it's still around. Artists Blacksmiths Association of North America. I guess I never knew what it actually stood for. They have like little social gatherings, and sometimes they make steel out of, you know, ores. And there's a video we'll watch with a bunch of, I guess, country folk, if you want to say that, making steel from the actual ores from a homemade oven, right? That's the old school way of doing it. But it shows you it's a direct reduction process, so you're taking the ores, you're reducing it down into a usable piece of sponge iron, and then you beat the hell out of it until it turns into a homogeneous bar of steel. That's all it is, it's a reduction process. They're going to start with these ores here. Magnetite. And it has 72.4% iron. Did I smell that right? Look at that, yeah. Metallurgy is one of the only courses that you teach that it underlines all the words, because, you know, Google doesn't even know what it is. That's one of the higher ones. Hematite is 68%. Limonite has 59.8%. Gothite is 62.9%. Siderite has 48.2%. Taconite is 25 to 35% iron. These are ores for making steel, right? They're different. There's different ores for aluminum, obviously. It's got to be rich in aluminum, right? This is rich in iron, so this is iron-based alloys, your ferrous metals. So a good question would be, why wouldn't you just get magnetite for every single, whoops, I did have to spell it wrong. Usually it underlines all of them, that's why I said maybe it's in there. So it's in there now. So why wouldn't you use magnetite for every time you were making steel? It's got 72.4%, it's got the most, right? Depends where it's found, right? If it's a difficult place to get, let's say you take the Rocky Mountains and you put a whole thing of magnetite underneath it. It's not exactly easy to get to, right? I'm not saying that's where it's found, I'm just using that as a general analogy. Or the bottom of the ocean, right? The deepest part of the ocean, is it easy to get down there? No. So, it's basically where they find these mines. They take it and pull it out. The steel making process, usually where they're doing that, it looks like the depths of hell, right? Because they have like trains going in and out with all that rock and coke, and you know, it's just. Ore dressing. Takes out a worthless rock. From the iron. So ore dressing has 3 ways this is done. First one is flotation. So it'll float on the top. With the weather. We don't care about the weather. Flotation. What do they do with the slag, by the way? Well, back in the day in Buffalo, New York.
Dump it.
Where at?
Sourdough.
Who's a fisherman?
Really.
You a fisherman? Where'd it go?
Freaking thousand.
Right in the lake. So there's a rule on, what's the rule on how many fish you can eat out of Lake Erie in like a year or something, isn't it? Or is it a week? Anybody know? There's a rule, you're not supposed to eat so much fish out of Lake Erie. Balls of mercury floating around on the bottom, right? Back in the day, waterways were used as garbage dumpsters, right? So, yeah. Now they just dump it on the ground. Really all it is minerals and things like that, but, you know, putting a huge amount of minerals into water is probably not a good idea, right? So, that takes you back to the, why is it still made in the United States as much as it used to be? It's because we have regulations, right? We actually care about the environment and things like that. Whereas in the land of China, not so much. Somebody in China's gonna see this, I'm kidding. Bodyguard? Would you lay your life on the line for me? I know the answer to that. Hell no.
I have to think about that.
Yeah, there you go. Here I thought we were close. So flotation, agglomeration. And one year I had somebody go, what's agglomeration? So I defined it. Agglomeration. Sound it out, right? What did they tell you to sound it out, like first grade? Sound it out, right? Agglomeration is to form into a ball or cluster. Last but not least, magnetic separation. We all know what magnetic is, right? Hopefully. Positive, negative. It's like magic, right? There's some pretty powerful magnets out there. You ever go to the scrapyard and see them lift the car up with a magnet? They like suck it right up and it's like not a big deal, right? I always got really paranoid when they would do that. Like, they're definitely gonna drop this thing on my truck. Like, there's no way. Have you ever heard of pig iron? Never heard of pig iron? Pig iron. And I had it was 2 years ago, I had a kid that would ask, like a 4-year-old, why, one of those, you know? Why is it called pig iron? I don't know, no idea. We looked it up, and it had little ingots lined up and it looked like piglets sucking on a model pig. That's why they call it pig iron. We confirmed it in the Wikipedia, which is not a real source, right? But yet every single person looks stuff up on Wikipedia, right? Do they let you do that in English yet? Is that still frowned upon?
I've done it in English a few times.
You use Wikipedia?
Yeah, he said it was alright for some things.
It used to be that was a
Mm-hmm.
major faux pas. But yeah, I used to write on the board all that kid's questions, and then I'd let everybody leave, and then we'd look them up, because he'd have so many freaking questions. They would take the whole hour, I mean, we'd be, you know, just answering those questions, but that's what it said. So If you look on the Wikipedia, that's what it'll say. All right, I checked with the guy, and I can look stuff up, and it's not a copyright infringement, so we can look that up. My plan was for anything that was a copyright infringement, I was gonna turn the cameras off at the end, and then do it with the cameras off, and then tell the other students to watch whatever I do for the online course, but I checked with the guy, and he said you can do Google searches and things, and it's not a copyright infringement, so. Hey, iron.
Hello.
Shh,
My bad.
no, that's copyrighted music, and here we go. There it is. Hence the name, here we go. We'll read it right here. When the metal had cooled and hardened, the smaller ingots, the pigs, in quotes, were simply broken from the runner, the sow, hence the name pig iron. Good news is they don't use pig iron anymore as much. So now you always have students, why do we need to know that if it's not used anymore? And the politically correct answer is, it's important due to its historical significance. You like that? It's important due to its historical significance. That's what it looks like anyways. Doesn't look too refined, right? So that's one of the, as you're breaking this down, it's putting it into, ingots that have a good amount of iron in it, but it definitely needs more refinement, right? You're not gonna do anything with those, right? You're gonna dump them back into something else, melt it down. So pig iron is what, lost it, what iron is, what iron ore, sorry, is turned into through a blast furnace. We're gonna go over the different types of furnaces here, probably next class, maybe today, see what happens. So it's a rough iron, I guess you could say, that needs to be broken down further in order to make it into usable materials, like an I-beam. Right? 3 main raw materials. Number 1. What's the first raw material? If you're making steel, there's 3 main raw materials.
Iron.
Iron ore, right? That's the obvious one, right? Iron ore is what is pulled from the ground. Next. Do we have any drug dealers in here? Are you shaking your head? Somebody said it.
Black tar.
Coke, right. Not cocaine, Coke. Coke, what do I have for definition? Basically pure carbon. Oh, I have the caps lock. You ever walk down railroad tracks and you see, it looks like charcoal laying all over the place? That's what it is. They dump it in, and usually they transport it on trains. Is pure carbon very heavy?
No.
No, it's not very heavy at all, is it? Last but not least, lime. If you want to raise the pH on your soil, what do you put down? Who's our farmers? Lime, right? No farmers?
Yes.
He's a farmer in the back, but he's a late farmer. When did you start farming?
Like 2005 is when this all started.
So probably like a year ago,
Say so, yeah, close to it.
ish. Late start farmers. They put lime on the fields, right?
Yeah,
Limestone, well, they put it in steel too. Limestone is limestone. I don't know how else to say it. Usually when they're talking about heats of steel, they say a heat, it's usually a round of when they're making it. One heat, I'll say, right? So, what goes in, they usually measure it in tons, by the way. So like, obviously steel is very heavy, so a ton, everybody knows what a ton is, hopefully, 2,000 pounds, right?
What about a gross ton?
Huh?
So what about a gross ton?
Can't hear you. I got a piece of plexiglass in front of me.
Oh, right,
You give me the baseball signals to let it go, man.
yeah.
All right, I'll let that go. What goes into 1 ton of iron? £2,000 of Fe, right? Oops. 2 tons of ore. One ton of coke. And half a ton of limestone. The baby cookies, right? So now you can sit there and ask the question, 3.5 tons makes 1 ton, right? What goes to the other, where's the other weight go? It gets burnt, it gets separated, it gets reduced, right? That's what they're doing, it's a reduction process, okay? They're taking dirt and turning it into something usable, right? Alright, where am I at? Sponge iron, enter. Sponge iron. Process in which small pellets of sponge are created containing 95% iron. So process in which small pellets of sponge are created containing 95% iron. They actually say pellets of sponge. It's not like a sponge like in the sink, right? It just like has a bunch of blowholes in it. Because the welders all know that at the atmosphere, as steel solidifies, you have to have something to keep the atmosphere out of the steel, or else it'll turn into, you know, a porosity-filled piece of sponge, basically. So so they're roughing it up, right? Again, it's just like the pig iron, the sponge iron is comparable. It needs to go for further processing, which I keep forgetting. I can look this up and not break the law. Sponge iron. There it is. looks just like the. Kinda looks like the pig iron, right? Same color, it's kinda like grayish. But if you smash that little pellet open, it's all full of holes because of the contamination. Needs to be further refined. Tunnel kiln. Only a few million tons are made yearly. Compared to 55 million tons of pig iron. Produced in a blast furnace. That's kind of old news. They've really switched to sponge iron, which the next bullet will kind of explain.
So what is the purpose of making sponge iron?
It's taking it from a rock, putting it into a movable format. You know, as you can see, that would fill like a train car really easily. And then moving on down the line for further processing. It's just basically like, I don't know, collecting drinking water before it's filtered. Does that make sense?
Gotcha.
You know what I mean? You need water, right? But you can't take it out of a puddle and drink. Well, I guess you could. But it needs to be filtered, right? Somehow. It's like rough cut Amish wood. Yeah. If you need to be pressure treated, you need to further refine it, right? There is an increasing demand for sponge iron and a rapid increase is expected. This data is fairly aged, so it's already kind of happened, if that makes sense. So sponge iron is actually pretty much taken over. The reason is sponge iron can be shipped more economically to industrial nations. Shipped to more industrial nations. So we're gonna go over raw iron real quick and then we'll go into the current steel making stuff. Next class. So wrought iron, everybody's heard of wrought iron, right? So wrought iron, everybody thinks of what? Gates, right? Wrought iron gates. You go over to the Institute, they all got wrought iron gates, right? They're made out of aluminum, don't let them fool you. You know, all that hand blacksmith stuff that you see, they just buy it. It's made in Mexico. Like small children, I'm just kidding. Watch this. There we go. Let's just go, you wanna go stair spindles? There we go. Look at that. See that basket? $9. Now, are you gonna sweat your ass off pounding that in front of a forge? You can buy it for $9? No, you're not. You're gonna buy it for $9. Then you're gonna go zzz, 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 zzz. Done, right? But wrought iron back in the day is iron that contains little or no carbon. To say 0% is pretty rough. There's gonna be a little bit of carbon in it, but. And the reason that back in the day they made wrought iron like that is because they did it with the blacksmith. And when blacksmiths are forming that into stuff, they're just hitting it with a hammer repeatedly, right? And every time they heat it up and hit it with a hammer, a little bit of carbon flakes off, right? So eventually it comes down with no carbon. No carbon is not a bad thing, or little carbon is not a bad thing. When you get high carbon, that's when you can get embrittlement and things like that. So that's why blacksmiths would beat it until there was a little bit more carbon in it. Here's your history lesson. In ancient times, it was produced by a process of direct reduction. What does that mean? The video we're going to see here in a minute, or it'll be in the next class depending on how much time we have. They're going to show you, they're going to do a kiln, they're going to throw the ore in, they're going to make it into a big chunk of sponge iron. They're going to take that sponge iron, if you want to put it into something that's useful, they're going to take it, put it on an anvil, and beat it until it's all together in one piece. Then you'll see carbon and dirt and stuff flying off of it as they do that. We obviously have better ways of doing that now, right? That's where your ovens and things come into play. The ore was heated in a forge. To a white heat to remove the impurities and to produce iron from the ore. The result is a pasty mass of sponge iron. Sponge iron is then pounded to remove the molten gangue or slag. Machinists, you know what slag is? You know, you guys are kind of grouped into different segregation here. We got machinists versus welders, huh? They desegregated to the schools, you know. You can all sit mixed up together, welder, machinist, welder, machinist. Welders will obviously know what slag is because they chip it all the time, but it's just basically minerals that have been pulled out of the actual, well, in the welding world it'd be a weld. In this world, it's just, they're trying to reduce it down, so they're pulling minerals off. Gangue is a little bit new of a word probably, that's a metallurgy term. Yeah, we want to insert a symbol, how do you do that? Let's see, insert, where's my symbols? Special characters, is that what it is? I want symbols, not special characters.
Same thing.
No, it's much different. See? Where's my bullet? They don't have a bullet under special characters? Let's use this light bulb looking thing. Yeah, that worked. There we go. Oh, I did like 3 of them. Does that mean something weird, or am I missing something here? No? Alright, good. That's supposed to be a bullet, I couldn't find a bullet, so I chose that. It's artistic. Gangue. The commercially worthless I wrote worthless in the notes twice, worthless, worthless. We'll only do one worthless. Mineral matter. Associated with economically valuable oh man, I butchered that. Metallic minerals in a deposit. Let's read that one more time. Commercially worthless mineral matter associated with economically valuable metallic minerals in a deposit. So it's the junk, right? Why is that underlined? It doesn't like deposit. Is that an E? Oh, that's wrong. It went away. I don't know. It's doing too much stuff for you nowadays, right? I feel like nobody can probably spell anymore, right? Spell check on everything, even your phones. If you're doing a job interview, that reminds me. Make sure if you can't spell, you take this thing called a dictionary. It's a ancient book used in ancient times that has the spelling of all the words. And I had a kid that filled out a job application. Well, first, let's go back. There was a sheet of aluminum that came in and I didn't want anybody to step on it. So I said, keep off on that because it'll bend, right? Aluminum if you step on it. He spelled it, keep O-O-F. Now he could have saved far on this because I went up to him, all right, very funny, change it. And he went, what? I'm like, you didn't do that on purpose? See, what he should have done is went, oh yeah. Found a dictionary. It's O-F-F, right? Not O-O-F, not oof. And he was dead serious. And this was like 10 years ago, so it wasn't, you know, as much computer stuff, but keep oof, he wrote on there. And then the same kid went and filled out a job application, and they called me up and asked me if it was a joke. And I had to, I mean, he ended up getting the job and everything was fine, but I had to explain to him that he could not spell at all. I won't mention what high school he went to, because we got cameras rolling here. As soon as I turn them off, I'll tell you though. Trying to see if there's anybody in here that actually went there and they could point and be like, yeah, you know what I'm talking about, but no. So if you don't know how to spell something, especially on a job application, make sure you take a dictionary with you, right? Alright. So yeah, we're gonna go over our next class, we're gonna go over all the ovens. We're gonna look at some stuff on Buffalo Steel. We'll have a little discussion on politics of the steel making. Very small, we don't do politics around here. We remain neutral. Yeah, we're not right, we're not left, we're in the middle.